Uh, so good afternoon. So today is our second live interacting session. So before we start, we will wait 2 to 3 minutes. Okay. Okay, we'll start. So so first of all, I welcome you all to this live interacting session on this subject, which is the conduction and convection heat transfer. So the course instructor is Professor Suman Chakraborty and Professor Shom. So I think that you all of you have gone through this first week and second week lesson, and also you have most of you have already seen this assignment that has been given on the first week and the second week, and already I have taken a live session on the previous week where I have discussed about this concept of conduction and convection. Right. So few of you, I am new to few of you, so that's why I am introducing myself. So I am Niloy, a PMRF scholar in the School of Mechanical Science, IIT Bhubaneswar, and I am your TA for this course. So if you are not understanding any concept, or if you have any doubts regarding this concept or whatever has been taught earlier, you can just on your mic and raise your concern. Okay. So before starting today's session, just a minute. So coming to this course details, so this course, why this course is vital for your curriculum? So because this heat transfer concept, this conduction and convection are one of the, there are basically three mode of heat transfer which you will study. One is the conduction, convection and radiation. So among these, this course will deals only with this conduction and convection heat transfer, because if these are the fundamental concepts that you will observe in your daily life phenomena, even in all the engineering field and even in our biological system, like our tissue, blood circulation through our tissue, you can see that whenever we have fever, our body temperature raises, and all these phenomena you will be easily able to understand the fundamental if you know this concept of conduction and convection, right? So the underlying concept of these two mode of heat transfer we will study in this course, along with the governing equation and how to derive this equation, what are the fundamental for this derivation, that thing we will study. So this courses is a 12-week course and we are in the second week. So if some, already many of you have enrolled for the exam, so it is advised to all of you that if some of you haven't enrolled for the exam, please enroll for the exam, because that will definitely help you to test your concept, whatever you have learned in this course. Okay, so the 13th February is the last date to register for the exam. So I encourage you all to register for this one. So So before coming to the contents of the second week, whatever we have studied in the first week we have discussed about this conduction and convection, how it differs from each other, and also this conduction equation, derivation of this conduction equation you have studied, right? So in this week we will deal with this boundary condition, conduction equation. Along with this boundary condition, we will solve some numerical. Along with, we will also see how an 1D steady state conduction equation looks along with some other condition. And apart from this, we will be dealing with this thermal resistance and how the thermal resistance concept is in mood with this conduction. So that thing we will study here. Okay. So I will recap few of the concepts that I have discussed in the previous lecture. So first, if I talk about this conduction, so what basically is conduction? So it's a mode of heat transfer which is because of this temperature gradient. Okay. So and the important thing that here there is no requirement of bulk motion of the medium, whereas convection it is because of a moving fluid. It is because of a moving fluid, and you if you remember, I have said in the earlier classes that if I talk about the primary mode of heat transfer, there are basically two primary mode of heat transfer. But in the Google or in books, you will find three types of primary mode of heat transfer. That is conduction, convection, and radiation. But as you will go on through these courses, you will understand that among this conduction and convection, the conduction is the primary mode of heat transfer, and the convection is conduction. If I say this, convection is conduction plus fluid motion. So both these thermodynamics part and this parts comes in as a single term, and it is known as convection. So that's why we consider this conduction as the primary mode of heat transfer. Okay. So here mainly the reason is temperature gradient. What is temperature gradient? So temperature gradient basically means the rate of change of temperature with the change of distance, or you can say change in the space. So it is the rate of change of temperature with the change in space. So in the conduction, there is no such criteria that the fluid motion is required. So we can consider that no fluid motion is there in conduction. Whereas convection, it is basically the conduction plus bulk fluid motion. Okay. So in the conduction, we have studied about this Fourier's law. So this Fourier's law, what it states that the heat flux is directly proportional to the negative temperature gradient. Say I consider it in one direction. So that's why I created del T by del T del X. So what basically it indicates, say this is the block. So you see this block, okay. So if I am applying an heat flux, so that is Q. So I represent it as say Q dot. So heat flux is basically the heat flow per unit area perpendicular to this surface. Okay. So that is the heat flux. So what I have said that the heat flux is is directly proportional to the negative temperature gradient, because see we know that the heat always transfer from the high temperature to low temperature. If it is T1 at this point and if it is T2 at this point, the heat will flow from T1 to T2. So that basically means here T1 is greater than T2, right? So that is the condition. So the if I talk about this gradient, if this block, if I consider these blocks in x and y axis, so this is your y axis, right, and this is your x axis. So if this is the origin, that means here x is 0 and here say small x is equal to capital X, or say L, right. So if I have to find this temperature gradient, so del T del X temperature gradient here is change in temperature. What is the final temperature? This is T2 minus T1 by what is the change in length? This is L minus 0. So basically you see as T1 is greater than T2, that means here T2 minus T1 is, so it should be less than 0. So that means it is negative. So to compensate for this negative temperature gradient, there is a negative sign before this del T del X. Okay. So that thing we have also discussed. I am just recapping this concept for you. Next, in case of this Newton's law of cooling, next for the conduction we have this Newton's law of cooling. What basically it states. So before this, another thing I just forgot here is that if I replace this proportional symbol, so I have to put a k. So what basically this k is, k here represent the thermal conductivity. So it is the property that is involving in this concept of the conduction. So this k implies how much heat the material will conduct. So it's the property that is involved in this concept of the conduction. Okay. So here k is your thermal conductivity. So similarly for convection we have this Newton's law of cooling, which is this Q proportional to Ts minus T infinity. So what is Ts minus T infinity? Basically if I talk about this surface, say this blue line, you observe this blue line. So air is flowing in the one side of these solid blocks. So the air is carrying certain temperature along with it. So that temperature I am representing here as T infinity. So because this surface, the wall of the surface that is exposed to the ambient having a surface temperature Ts or T2. So is this T2, say it is Ts here. So this Ts and T infinity have certain temperature difference. As there is temperature difference, so definitely the heat will flow from high temperature to low temperature. But why the heat will transfer here? Because of the bulk motion of the fluid, as I have already said, that this motion is because of the ambient motion of this ambient air, right? So that's why this Newton's law of cooling, it states that because of this gradient, sorry, because of this temperature difference between the bulk motion of the fluid and the surface temperature, so there will be a heat transfer, and that is known as convection. So if I replace here, if I replace in this proportional symbol, I have to put a h constant, proportionally constant h, where h indicates the heat transfer coefficient. Okay, this is your heat transfer coefficient. So here you see that this convection is happening at the interface. Interface means that here is the solid surface and this is the ambient air. So that is between fluid and the solid. So that's why this convection is happening at the interface, whereas this conduction is happening inside the material. Okay, if I talk about the speed of the among these two mode of heat transfer, generally this convection is a faster mode of heat transfer in case of fluid. But if I talk about a metal, the heat transfer is generally more for the metal. Okay, so that is the concept I have already discussed in the earlier class, and I am just elaborating this one for your understanding. So another important thing is that as this today's session is based on this conduction and convection, so first is why the heat conduction is in solid happens. That means what are the fundamentals behind it. So basically in solid, if I talk about a solid, the heat is transferred mainly because of two microscopic mechanism. Two microscopic mechanism. This is I am talking about this conduction. So the first is that free electron movement. So you know this free electron movement, that is in metal. If there is a free electron movement, you know that electricity can easily move. Similarly, if there is free electron movement, the heat can also move. So an electron gain energy. If I am talking about a rod, so if this is the metallic rod, so if I am applying heat, okay, so the electron at this end is gaining energy because of this heat, and because as it is gaining energy, it will try to transfer the heat to the colder end, because that is the thermodynamic law. It will transfer, energy can neither be created nor be destroyed, it can be transferred from one form to another. So basically as it is gaining some energy, extra energy, so it will try to transfer to the next electron. So that's why this heat transfer is taking place, and as the atom or the electron is taking this energy, it will collide with the next electron and next electron, and because of this heat transfer happen. And if it is not a metal, say any other material, so in that material basically the heat transfer is happening because of the lattice vibration. Okay, so what is lattice? So if I talk about this lattice, if in any solid, a solid body, the atoms, if you talk about these atoms are not placed randomly. So what happened, they are arranged in a manner such that it is having a three-dimensional pattern. Okay, so any atom is placed, you have studied it in class 12 in chemistry, I think. So in a block, see, this atom is there. So all these atoms are arranged in a certain 3D order pattern. Okay, it is fixed. It may be a cube, it may be a, sphere, any types of shape. It may be random shape, anything. That means it should be crystal-like arrangement. So that is known as your lattice vibration. So if I talk about a solid, if this is a solid, so this solid consists of a certain number of lattice, and each and every lattice having atoms in it. So because of this, the atom, we are hitting an atom, so it is getting excited, and because of this it started to vibrate. So as because of this vibration is transferred to this nearing atoms. Okay, so that's why this, because of this vibration, the vibration of the atom is correlating with this vibration of the lattice. So that's why the heat is transferred in case of the conduction. So these are the two microscopic mechanism. Okay. So any confusion up to this, please raise your concern. You can on your mic and ask question. Yes, yes, definitely. Just a minute. say the just this is a solid block. Okay, so I am just plotting it in x and y axis. X, this is y axis and this is your x axis. So say I am applying heat here. So this is an heat flux Q. Okay. So this heat flux I am applying here to a solid. And because of this there is a certain temperature. Say this one temperature is T1 and this one is your say Ts. Okay. So as it is a metal, so the heat transfer here is taking because of this conduction, right? So this surface is having some temperature. Say now I am just flowing some air at this end. Okay. So just you can analog this pattern with a cup of tea. So in a cup of tea, if someone gives you a cup of tea, it is having some hot tea, so it will take certain time to cool, right? But if you are in a hurry, what you do? You just blow air above this cup of tea, right? The similar thing we are doing here. That means in this solid box, along this end, any end, say this is the your this surface is exposed at temperature Ts, and we are blowing air. So and the temperature of this air is T infinity. Okay, what is the function of this air, blowing air? So this air basically is used to transfer the heat from this solid block so that it get cools. So that's why this name comes cooling. Okay, so basically as I know that when heat will transfer if there is a temperature difference, right? That is from high temperature to low temperature. So that's why if Ts there is a temperature, say this Ts and T infinity, there is a temperature difference. Say Ts is greater than T infinity. So the heat will transfer in this case. So the how the heat will transfer? The heat will transfer here, it will be inversely proportional to the temperature difference between two. How much? If the temperature difference is more, the heat transfer will be more. If the temperature difference is less, the heat transfer will be less. Like in this cup of tea, if you are blowing hot air above it, so it will not cool quickly. But if you are blowing cold air, it will cool quickly. So that means the temperature difference between this solid surface and this bulk fluid is quite important in case of cooling. So that's why this is your Newton's law of cooling. So this is proportional. So if I replace this proportionality, I have to put a constant. So I just replace this constant with h, where your h is the heat transfer coefficient. So for this convection, what you require? For this convection, you need a bulk fluid motion that moves along a solid surface. Okay, you got it? Okay, can I move to the next one? Next concept? Oh, thank you. So up to this, it's okay. So we are now dealing with an energy balance equation. Energy balance equation. So energy balance equation basically means if this is a block, whatever energy is entering into this system, this is energy in, and whatever the energy is going out of this system, say this is a control volume. You know control volume. So this is a small volume inside a domain where we are just dealing with. Say if I talk about this is a house. So you are a engineer, so you have to test whether this house is whether cement used in this house is good or not. So you will not test whole the cement. So you will just take a portion of the cement from somewhere from this wall, right? The, and after that you will test the cement to check whether this is a good one or not. And based on this you will put a report that yeah, the cement is good or the cement is bad. So you are just taking a small sample. So similarly, a control volume is a small sample. If I analog this one in with your real life scenario, so this control volume is a small sample where you will study the fundamental. So you can say that whatever is happening in this control volume, the same thing is happening on a larger body. Okay, so this is a microscopic study, you can also say. So whatever the energy in and energy out minus energy out, this is the rate. This dot indicate rate. What is rate? Rate basically here represent the change in energy with respect to time. This dot indicate the change in energy with respect to time. Okay, and say already the system is generating some energy. So I replace it as your energy generation. So this is your energy generation. So whatever is inside is going into the system and whatever is coming out plus this energy generation, this equal to net energy in the system. Okay, so that basically is the concept. So I think in the lecture that is given by Professor Chakraborty, here he has given a good example, that is the if it is you have to analog this one, you just take the concept of a bank account. So you are just investing some amount, say some amount you are investing, okay, say rupees 10,000 you are in rupees 1,000 you are investing, and you require you after a few days you just withdraw 500, sorry, it is 10,000 say. So 10,000 you are depositing, and after few days you are withdrawing 5,000. So here this is your amount in, okay, and this is your amount out, right? So if you have some amount in the bank, you know the bank is giving some interest. So that interest here is your amount generated. That is that amount is given by the bank. So which is the interest? Say this amount is your say rupees 100. Okay. So after a month, so this is the input at the starting of the month, and this is the interest, and this is the out. This is the amount you are withdrawing at a definite month. Say in the month of January. So what is the amount left in the account? This is your 10,000 minus 500 plus 100. So that basically is 5,100. So the same is the concept. So this one is your amount in, this one is your amount out. So this one is your interest, and this is the remaining amount in the account. Okay. So this same concept is used in this in your syllabus for this energy balance. As we are talking about this conduction, initially we will talk about this conduction. So after derivation of a certain a lengthy derivation is there, so which already the Professor Chakraborty has discussed. So you please go through this derivation, and if you are not able to understand this derivation, you let me know in the next class. I will even today I will elaborate the concept or whatever the steps you are not understanding. So I am just writing this equation for you. That means this conduction equation. Okay. So this conduction equation is your, sorry, say these two terms. I am writing whatever is derived from this part. Say for a 3D body, that means this is a solid block, and consider the heat is transferred in all direction. Okay, like an ice. If you place an ice in an open air, the heat will transfer from all the end. So in certain case, what has been found out, it is ddx of your qx. Qx is your heat flux plus, that means the change in heat flux in x direction plus change in heat flux in y direction plus change in heat flux in z direction. This one you what say, this is energy in minus energy out, that means change in energy. Okay, that's why this is change in energy in the x direction, whatever be the change in the, this is your x direction, say this is your y direction and this is your z direction. Okay, plus energy generation term is there, so uh, I represent this energy generation term as q, capital Q dash. Okay, triple dash. So this is your energy generation. So that means the energy coming from outside from the system, because of, like, it's like the interest I am talking about in case of the money balance, plus your net energy. So this net energy, what have been found out, this net energy is proportional to this rho Cp, okay, minus del P del T. So this is the equation what we are getting, right? So can I erase the top part, this one? Up to this, any confusion? So okay, so I am just erasing this one, because remembering this equation is quite tough. Even many of you do not remember this. So how to remember this one? So you are in which year, Shashwat? Third year. Okay, so you know this divergence, gradient, curl. Yeah, okay, so that will be easy for you to understand this concept. So this equation, how you will remember this conduction equation? This is your heat conduction equation. Equation, right? So be precise. If I write this term in case of a solid, for solid, basically what we observe that this beta. What is beta? Beta is a thermal expansion. So this thermal expansion is almost negligible. So we consider it as 0 for solid. Okay, because here we are talking about conduction in solid, so that's why we are considering these terms as 0. And also in a solid, if whatever the pressure change in the both end or pressure change inside the solid is negligible. Okay, so we are ignoring this term, right? So what I can write? I can write it as rho Cp del change in, right? And this one is your all this term. So I can write it as, so this one is your del operation, del cube. Can I write? So what basically is del operation? So del operation, if I talk about, if I give a vector, this one is basically d dx of I cap plus dy of j cap plus k cap, if it is a vector. Okay, uh, but if it is not, then I j cap is not required. So you just, that means here if you just put, you will get this term. Okay, so now if I talk about this q here, so from the Fourier's law, what we have? What we have from the Fourier's law? Uh, minus, this is heat flux. So A is already there in the Q. This Q means capital Q by A. So that's why dt by dx, right? Okay. So basically here the heat flux, I just forgot to mention, here is a negative sign in the front, not here. Rate of, because we know that heat flux is, why this negative sign is there? Negative sign indicate that the temperature gradient and the heat transfer is taking place in the negative temperature gradient direction. So to compensate it, this minus sign is there. Okay, so that is your formula here. So in similarly I can write qy is minus ky, right? Qz is minus kz. Can I write? So from this equation that is written in green color, so from this equation, now this minus is there in all these three, minus is there q. So I can write minus del x of, in place of here I can write kx minus plus, sorry, plus, so this is the left hand side, plus q triple dash, this is rho cp, this one, right? So if I now consider that if the thermal conductivity is same in the x direction, y direction, z direction, in all the direction, if the thermal conductivity is same, so what will happen? That means I can write it as, the minus will come out and it will become a positive in all case. Say if I can assume kx, ky Kz means thermal conductivity in all the direction are same. Say it is Sk. So as it is a constant, this K will come out here, right? So if K will come out, this equation will look like this. Yes or no? Okay. Z square plus Q. So many of the students get confused with these two format of the equation. Basically, this format is if the thermal conductivity is different in x, y, z direction. But if it is same in all the three direction, then this form is required. So now I can write it as this one is your, if I divided it by k in both sides, so what I will get? Sorry, not y square, and sorry, yx square plus d square t plus dz square plus q by k rho cp by k. That will be the format. So this thing means I'm talking about this part. So can I write this part like that one? So can I write this one dash square, right? Hmm. Plus q triple dash by k, and this term, what is this term known as? Can you know? Yes, thermal diffusivity basically is k by rho Cp. What basically it indicate? Thermal diffusivity, it's okay. What basically it indicate? Can you tell? Okay, I'm just telling this thing. Basically, this concept of this thermal diffusivity. So in the numerator, what is there? K is there, right? So basically, it indicates that, say, a solid block. In a solid block, how much the heat is conducted, and the below part indicate how much the it is thermally storing this energy. The whatever energy is conducted into the system, and among this conducted energy and how much the system is storing the energy, that basically represent this your thermal diffusivity alpha. Have you got it? Say if I talk about, say, if you are conducting as 100 joule of energy, conducting 100 joule into a system, and if it is storing 20 joule energy there, so that basically is represented by lambda. So you can say, if your lambda is more, sorry, alpha is more, what does indicate? That indicate the system is not storing the sufficient energy. If the alpha is less, that means whatever the system is conducting and whatever the system is storing, that is, there is a little gap. So that means it is storing more energy. Got it? Okay. So this is your format. Okay. So this format we will understand. So there are certain different certain what I can say. There are certain condition to apply this equation. So I am moving to the next one. So before this, I am erasing this one. Say now I am talking about this boundary condition. Say we have some numerical problem to solve. So before this, I am just giving you this fundamental concept so that you will be able to solve a few of them. So boundary condition, there are three types of boundary condition. First is, so the spelling may be wrong, I am not sure. Dirichlet boundary condition. Next is, third is mixed boundary condition. Okay, so this is a block. So you have got an equation in the previous, what that equation is? This equation, if I recall, T plus 1 by alpha. This one is your equation, right? This is the equation I have got in the last slide. Yes or no? So if I say it is a steady state, what basically is a steady state? If someone say the problem is a steady state means the property, say temperature, pressure, or anything doesn't changes with time. That means say if you have a thermoflux, if the water temperature inside the thermoflux is at 50 degree at 6 p.m. and again at same pm 7 p.m. if you measure the temperature and it is found to be 50 degree, that means though the time is changing but the temperature is not changing, so that is known as steady state. That means the property will not change with time. Okay, so this, because it is a steady state, that means here change in time with change in temperature with respect to time will be, yes or no? So that's why this terms is zero. And say in a problem it is given that this your Q can be zero. Say that there is no internal heat generation. In that case, it will be zero, and the equation will be del square T equal to zero. Okay, but we are considering here only for the steady state. So for the steady state, this equation becomes, so question in the exam question can be like this. So write the heat conduction equation for steady state. If you write up to this part, it will be okay. This is your generalized equation. Okay. Now if someone say write it in 1D. For 1D, 1D means only say in x direction. Say x direction. That means the in the previous you have studied about dt dx dt dy. So dt dy dt dz, that is not required. So this is the gradient square. That means I can write it as del square plus, can I write? So, so since it is in partial derivative form, so where you will use partial derivative, we generally use partial derivative if there is two direction, but for one direction, partial derivative is not necessary. So that's why you can see in book it is written as normal derivative form. So the normal derivative form is written if it is in 1D. But if it is in multi direction, then you need to write it in partial derivative form. Please remember this thing. Okay, just a minute. So I am talking about this your whatever talk about this boundary condition. Say this is a block. Okay. Now my target is to solve this equation, or you can say this equation. More precisely, we have to solve this equation because we are dealing with only x direction. Say we are dealing with only x direction. Say this boundary condition basically means if we are supplying the heat, or say in the Dirichlet boundary condition, you basically have a specific value given, say temperature, fixed temperature is given. Okay, so this boundary condition is basically means in this wall you know the temperature. Say this temperature is given as 50 degrees C. So that types of boundary condition is known as Dirichlet boundary condition. For the Newman boundary condition, it basically represents that at a wall, say there are two walls, this wall and this wall. At this wall, you are given dt dx. And that means temperature gradient, fixed temperature gradient is given. So what basically is temperature gradient? Can you say? So what basically this implies? This basically implies your heat flux, because you have studied na q proportional to from the Fourier law, right? So basically if the temperature gradient is given, that indirectly means that heat flux is given also. So Newman's that means temperature gradient or heat flux or heat. Have you got the concept? Now if I talked about a mixed boundary condition basically means is a combination of both these two. That means here what I am saying, that the fixed temperature gradient, that means del T del X should be a value. But if say this del T del X is a function of time, then it is a mixed boundary condition. In the first case, you know the temperature is a constant. It will not change with time, or it will not change with the distance. Right? At this line, it is always fixed. And here del T del X is fixed. It will not change with time. But in the mixed boundary condition, del T del X is a function of time. You got it? Okay. So just a minute, I am showing some example. I think that will help you to understand. Can I have the example? Just a minute. Where is my Yes. Hmm. Which boundary condition? Mixed boundary condition. Yes. Definitely, definitely. And that is actually, I also planning to provide you with a certain example where you need this concept. Okay. So that will definitely help you. But I will start with the first two condition and after that mixed condition. Is it okay for you? Okay, just a minute. Just 1 minute. Okay. Hmm. So to solve this one, this page I am erasing. So for the first question, first the listed boundary condition. So basically say this is a U rod, this is a rod. Okay. So in this rod, it is in one direction, only in X direction I am talking about. And it is a steady state. If I said it is a steady state, no heat generation. Okay. So that basically means steady state means what I can say. I know the equation. So first always remember this equation because that will help you to remember to derive the main fundamental equation 1 by alpha to 1 by del t del. So that one is 0 and this one is 0. So for steady state no heat generation the heat conduction equation becomes this one. Is it okay? So now just say I am applying heat here. Similarly, if I am applying heat here, say this heat flux here at the heat flux at the this region, say this is x is 0, this is x is L. That means at 0 and this is at QL. So say this heat flux is given as sorry, this is not the first boundary condition, this is the second Newman boundary condition, and this one is. So that means say here whatever the heat is entering into the system, the same heat is coming out here, right? Hmm. So now I have to solve the equation. So if I have to solve the equation here, so can you see that this equation, so I can write since it is a 1D conduction equation, that means I can write as dx square equal to 0. So if you integrate, what you will get? You will get constant, because we know that the derivative of a constant is 0. That's why integrating you. Is it correct? Okay. So so you see here, so this thing you have got. So now at x equal to 0, what we have? We have q 0 is 1, right? So what basically is q 0? That means k del t del x equal to 1. Say I consider this k as 1. Okay. For this question, if I consider this k as 1, so what basically I will get? What is the value of c1? Sorry, there is a minus na. Acha, okay. So basically I can write delta in place of delta I can write c1 1 into c1 equal to 1. So c1 is minus 1, right? So what I will get here, del t del x is your minus 1. So again if I integrate it, what I will get, t is minus minus x plus c2. Okay, so now you need a boundary condition to solve. Say here what are the two variable, x and temperature. So to solve this here you need a what boundary condition? First boundary condition, that is the Dirichlet boundary condition is required, without which you will not get the certain value of t. Yes. So in the gate question, say up to this, just they can say what is the slope of this graph. Say if it is t, it is x. So how this graph will look like this one, negative slope. So similar types of question can be asked in the exam. So for to solve this equation, though it is a solution, but it is having how many solution? As the value of the C2 is not known, so this equation has how many solution? Infinite solution. C2 can be anything now. But if in the certain condition, say if it is given at x equal to 1, uh, t equal 1, say certain condition is given. So in that case you can put at x is 1, t is 1. That means 1 minus 1 plus C2. So C2 is 2 in that case. So you will get x is minus plus 2, right? So the main thing what I want to tell you is that first you need to understand how to derive this according to the question, if it is steady state or not, if heat generation is then some student always start from this part. That is not correct. So this comes because in the question it is given steady state no heat generation. Please remember this thing, okay? So that's why in sometime in gate the student make mistake. In some question they are saying that the heat generation is this much. The student says that in this equation there is no heat generation term, and they solve this question and get an answer, and eventually they get negative marks. Okay. So the first is this thing. So I am just giving you another example. So this is your fundamental example, and after this I have some numerical question that is based on previous year assignment. Okay. Just I am giving you whatever you have understand. I think just T. I am giving a profile of T. T x y z. Okay. This is x square minus 2y square plus z square plus, sorry, minus xy plus 2yz. This is given. So this is the temperature profile along xyz direction. So you are asked, the question is that find the region where t changes with t. So I think you have solved this in lecture also. Okay. So basically the temperature profile is given. You are asked to find where t changes with time. So this is your nothing. This question you have to find the, so t changes with time. Basically you have to find del t. This one you need to find. Okay. You got the question? So can you solve? Okay. You just solve and tell because I have to show it. So again, we know that del square t plus, say, heat generation. Assume as nothing is given about heat generation, so I consider it as 0. So I can write this as 1 by alpha del t. So this one basically means your derivative of t with respect to x plus x is double derivative with respect to y square plus double derivative of 2 with respect to z square. So individually I need to find. So if I have to find with respect to x square, uh, first I find with respect to single derivative I do. That means with respect to x it is 2x minus y. This one will be 0, this one will be 0, this one will y, this thing, and after, and we will get 2, right? Y square. Similarly, first I derive derivative with respect to y, then this is minus 4y minus x plus 2z, again my derivative with minus 4. Next with respect to z square, what I get, first term is 0, second is 0, next is 2z plus 2y. So ultimately I will get 2. So if I add all these three here, 2 minus 4 plus 2, this is your 0. So ultimately your del square t is 0, right? So from this equation, what I will get, 0 is 1 minus infinity del t. That means, so there is no such reason where the temperature is changing with time. Yes, it is an example of steady state. So basically in each of, in both the question, you see you need to find out the derivative. In the previous question this one is given, right? So del t square equal to 0, this one is given. As because it is in derivative form, you need to integrate to find the temperature. So from derivative, if you need to find the temperature, you have to integrate. But if the temperature profile is given, you need to derivative to find the equation. Can you get the uh, correlation among these? Okay. So this one is okay. So next numerical concept. Next is your one question based on your, what is that? say a block is there. This is a plate. Okay, so this plate, this one is your x is 0 and this one is x is L. Okay, total length is your 0.3 meter. I am not writing the question, I am just drawing the diagram. If you are not able to understand, you please let me know. Okay, so this one is your T1, this one is your say Ts or T2, whatever you want you write. So this one value is given as say 200 degrees centigrade. Okay, and this value is given as Ts, the value of Ts is given as 142.7 degrees centigrade, right? This one is given, and another thing is given the temperature profile. As it is in one direction, the temperature profile is given 200 minus 200x plus 30x square. This means how the temperature changes in the x direction. This profile gives. Okay. Now the question, now what is given? Say an air is flowing. Here an air is flowing. So the temperature of the air is around 100 degree. Just it is in 100 degree. So and k, the value of k is given as 1. Okay. The first question is find surface heat flux. Okay. The next question is find rate of change of wall storage. Next is the find H, heat transfer coefficient. Can you get the question? It seems to be a tricky one, right? Or easy one. So it has given everything here. So first you just think of the question and let me know whether you understand the question or not. After that I will show you the solution. How it is linear? It is the changes with x na x square. It is not linear. Just check. Surface heat flux. That means you have to find out the heat flux here and heat flux here. First question, if I write, so what they are saying, they are asking you to find Q at x equal to 0 and Q at x equal to L. Net change of wall storage. What basically it represent? It represent matlab how much heat is entering and how much heat is releasing. That means you can write say x, whatever the heat flux is getting, the inlet minus heat flux is, this one is basically your concept. Okay. and H. In the third question, you need the idea of the mixed boundary condition. So before that, first try to solve the first two questions. So I am helping you. You just solve, and if you get the answer, you just tell me. So first you say, here you see that you need to find q x equal to 0. So what is q basically is minus k, right? So if I derivative it, I will get na del t del x minus 200 plus 60x. So here minus k means k is given as 1, and del t del x equal to 0, you have to put minus 200 plus 60 into 0. That means your 200 is your heat flux. Similarly, find this one and tell what is the answer. What you get? 182, yes. That means whatever the heat is entering into the system and whatever is remaining the it is not the same. That means something is storing. So if something is storing, which concept come? The concept of alpha comes. That means thermal diffusivity. You got it? So that's why in the next part, in the question, this one is your question one. In the question two, you have to find this one is asked, which is basically your, the answer is your this one, right? Huh. After this, no confusion. Now you have to find out the heat flux. So I am erasing this thing. Hmm. Huh. Yes, convection is equal to this. Say for this, always remember why we are using the convection equal to conduction. This is because your the convection. If I talk about this convection, where convection happen? Can you tell? Huh. At- In the in the presence of moving fluid, it should be moving fluid, okay, and it take place at the interface. Interface. Say if I talk about this surface, let me show you with another color. So this black color surface you observe. So this is your solid surface. This solid surface is having Ts. So as there is a temperature, so an heat flux is there, right? So this heat flux here, this is because of your conduction, and because air is flowing outside, so outside also the temperature will reduce because of convection. So that's why this is your convection. So this is your mixed boundary condition. Why it is a mixed boundary condition? Say here, what is conduction? Conduction basically, if I talk about conduction, so it is basically proportional to right? And if I talk about convection, what it is basically? T- TS. So what is the mixed boundary condition? That means what I have said, del T del X should be a function of time, right? So see, if it is proportional to this and it is proportional to t, so I can write now del T del X is a function of t. So mixed boundary condition basically indicate implies both conduction and convection should be there. So that is a simple how you got to know that whether it is a conduction or convection problem. Mixed boundary condition means this thing. It is not necessary that mixed boundary condition only implies conduction and convection. Maybe it indicates radiation. You can say how radiation. Say just in this problem. So in this problem, if you have to solve, you have to show that this Q conduction at x equal to L should be equal to Q convection, right? Because whatever the heat flux is at the surface and whatever the heat flowing out of that should be equal. Is it okay? Huh. So that is the condition here. So I got it. I got the value. What I got here? Just tell me the value. 182. I just 182. This is H T infinity minus. This is your 100. Sorry, 100 minus 142.7. This is your 182. Okay. So you can find H. So this is your uh, mixed boundary condition. Say in the mixed boundary condition, sometimes it happens that there is radiation. In the question say that the radiation is happening. With convection, radiation is also happening. So there will another terms come which is because of why radiation is added to this convection side, because in the solid in the surface what is coming, the heat flux is coming, and this heat flux is releasing because of convection and radiation. That's why this radiation terms will come. So in that case radiation, what is the formula? Sigma, uh, sigma in E na. What I remember, I just forgot this one, to the power 4 minus Ts to the power 4. So that thing, if in the question it is saying that radiation is there, you have to include this part. So that is how the gate try to test your knowledge. So how you have understand this concept. So I think it is okay. So just tell me the answer. Huh. Good. This is your 4.26 watt per meter square Kelvin or degree centigrade, whatever you wish you can write. Okay, so I'm moving to the next problem. So, what? Yes. Hmm. in the unit of. Huh, hmm, huh, huh, huh. No, not necessary. Because why you need not need to change it? Because see, here H is a function. If I talk about this is temperature difference, right? So the temperature difference, whatever be the temperature difference in Kelvin and degree centigrade, that should be same, right now. So if you 100 degree minus 80 degree, that is your 20 degree, right? 20 degree centigrade. If you convert 100 degree into Kelvin, you will get 373, right? And 80 degree into Kelvin, that is 353. After that, if you subtract, you will get 20 Kelvin. So the 20 Kelvin or 20 degree centigrade is same if it is a temperature difference. So no need to change Kelvin into degree centigrade in H. So, okay. So I'm moving to the next one. Huh. So it is a fundamental question. Can you answer this one? Just try and let me know. Yes, yes, the option C is the correct, because what I have said that the heat conduction in solid, if it is a metal, this is purely because of flow of free electron. That is correct. But in other things, it is because of the vibration of the lattice. So that's why option C is the correct option. Okay. So next the question is, so acha work. Okay, so this is a question. In this question, what is given that it is a steady state heat conduction across a thickness in a plane wall of thickness 6 centimeter. The wall has a normal area of 2 meters square and has made up of material. Thermal conductivity is given, area is given, thickness or L is given, temperature on the two side is given. You are asked to find out the thermal resistance. So see, I think that I have forgotten to tell you that this Q is your minus K del T del X, right? So if I am, it is a block. If this cross sectional area is A, okay, this is K, this is your T1, this one is your T2, and consider it is in Y direction, it is in X direction. So this point is your x equal to 0 and this is your x equal to L, right? So here I can write Q heat flux. Q means here heat flux minus K. What is delta here? Change in temperature. Final temperature is your T2. T2 minus T1. In place of del X, this one is your del X. Change in distance. So this one is your L minus 0. So ultimately I can write, if I take minus inside, this one is T1 minus T2 by L, right? So if I have to find Q, what is Q? Q equal to this into area, right? So just see, can I write Q is by L by Ka. Okay. So this L by Ka is known as your thermal resistance. It is analog to the resistance of a circuit. Like if I draw this thing, I'm talking about this thing. Here there is T1, here there is T2. So what is the resistance? The resistance is L by Ka, or heat is flowing from which direction? High temperature to low temperature Q. So that is our analog circuit. Okay. So based on this concept, you have to try to find out this one and let me know. I am giving you 2 minute time. Okay. L upon K. And remember one thing, it is 6 centimeter. So everything should and all other thing are in meter. So you have to convert it into meter. Yes, yes, that is the question. So it is a simple question, but if you see the question, it looks like a complicated one, right? So why it is Q required? So that is why that's how the people who set the gate question is able to confuse student. So basically, in the question, maybe a lot of details are given that is not required. Like the temperature in the two side, 600 and 300 is not required. So it is required if you are asked to find heat, Q. So if Q is asked, then already you know the thermal resistance which is getting as 0.06 and in the temperature difference by here you will get Q. So at that case, maybe it is required. Okay. So option C is the correct option. So I am moving to the next question. Hmm. So this is also the conduction heat conduction equation. It's a general form. You are asked which of these following is the general form. So please try to solve this one. Just remember this equation and try to solve. This is the first form where I have kept C del square T is the form when I have taken the K constant in all direction, right? But here maybe it is possible or not possible. It is not given. So you just check which one will be the form. I am giving you 1 minute. Please solve. So, are you able to solve this one? Okay, please try. Ah, yes, good. Option B is the correct answer. Very good. So basically, the equation is that if you recall, just I'm writing this equation in the full form. This one is basically your kx del t del x. So here k is the thermal conductivity, although given like ky del t del y del t k z del t del z plus q. This is the equation. Plus beta term is there, which I have said that not required. So this one equation I can write. It's a given. It is a steady state. That means del t. So this one is getting 0, right? So before writing in the equation, the rho Cp is there. So in all of the equation. So before putting it here, I can write now. Just one. I do one thing. I just replace rho to from here, and I just put it rho Cp rho Cp. Okay. So this del dx, this thing, say by this term plus this term, this is your del operation. So I can write 0 equal to del k. I can write k, or again this is your del term. So k del t. Okay. So that is the thing. So that is the equation written. If the k is constant, it will come out and it will become del square t, right? So that's why this equation is looking like this format. And remember one thing, in the above equation, this equation, say when rho Cp was there, okay. So if rho Cp was there with del t, this term or this term, and only this term, this all of this term are in per unit volume term. That means if this is the what is Q triple dash, this is your heat generation, right? So the heat generation here indicate the heat generation per unit volume. That means if the unit of heat generation is watt, but here Q triple dash means watt per centimeter, watt per meter cube. So each and every term should be in meter cube. Okay. So the correct option is option B. Okay. Next is a question. Next is a lengthy question. In this question consists of 4 to 5 question, not 10 question. I am just writing 3 question. It is 4 to 6. Maybe large number of question may comes, but this is the question. So what is given? A plane wall of thickness 12 is given. It is the volumetric heat source is given. Volumetric heat source. That means that value of Q is given. Q generation. This one is your Q generation is given. Okay. Temperature at both ends is given. That means this point is your x equal to 0 and this is your x equal to L and this one is your x equal to minus L, right? So temperature at both ends are same. That means it is TW and this is also TW. And at x equal to this one, at this point, U del T del x equal, what does that indicate? Hmm. The no, the graph is a what I can call it's a steady point. Not a steady point. In maths, I just forgot the name. That means the slope is neither increasing or not decreasing. This is certain point. Uh, Equal on both sides. But if I talk about the physical importance of this del t del x equal to 0, what does that mean? You whatever you have said is based on the graph. But now in terms of heat transfer, what del t del x means? Your uh, not directly. Del T del X means your temperature gradient is 0, right? That means here heat flux is, uh, so that's how you have to, you got it? Uh, so the question you understand? So can you solve this one? Not complicated, you just tell me. So I am not solving, just you tell me and I will try to solve like this. So what is the equation? Just tell me the equation, heat conduction equation. It is in x direction, one dimensional equation. Uh, uh, Plus heat generation is equals to 0. Okay. Uh, there is a term k is there. Okay. Rest of the equation. It is okay. So in the question, this q generation is given, right? So can I write del square t by del x square equal to minus q gen by k? What is q gen? Hmm. Q double dash by k is there, k l square. Now what I need to do? You got this thing. You just remember this thing because I have to move to the next page to solve this one. Okay. Or either you can take screenshot also if you want. So after that, what we can do? If it is in derivative form. So what if we have to find the temperature? What you need to do? Yes, good. So if I integrate it, what I will get? Del t del x, right? So the constant will come out first. So next integration of L square into what will integration? Integration of L square? No, it is with respect to x na. L square is constant na. तो L square into x होगा ना. हाँ, and x is variable. X square integration of x square is x cube by 3 plus up to this, okay? So I'm moving to the next place. Just remember this equation and tell me, because in the next slide I will forward this one. So I am just plotting this one graph. Here it is x, it is tw, it is also tw. This is your x equal to minus l into l, x equal to 0. Here it is given del t del x at x equal to 0 is 0, right? So what I got, del t del x, this is your minus q double dash k l square l square s cube by 3 plus a constant, because integration, in integration there is a constant, right? So now the boundary condition. So which boundary condition? Three boundary condition are there, na? In the question, if you watch, the first is that a temperature at the board tent at x equal to plus minus 1 are same, that is Tw. At x equal to L, T equal to Tw, and at x equal to 0, del T del x equal to 0, right? So both the first boundary condition is what? This is your Dirichlet boundary condition, and the next one is your Newman boundary condition. So see here, this one is given del T del x. That means Newman boundary condition is given. So I can write now, if x equal to 0, what I have, del T del x is 0. I put it here, so I can get 0 means minus, it is 0 minus 0, right? Yes or no? X, I just put the value of x here, so I get C1 is 0. So what the equation will look like above equation, I just write it with another color. So I get del T del x minus q double dash by k L square x minus x cube by 3, because this C1 is 0. But our objective is to find what? What is our objective? That means temperature, right? So again, if it is in derivative form, so to find temperature, what I need to do? So integrate it, I get T equal to how much? What? The first part is constant, so it will come out. Integration of this one, just tell. X minus 3 is there na, 12, right? Plus C2. Is it okay? And now I have to apply another boundary condition. Which boundary condition? You can apply any of the two. L x equal to minus L, if x equal to minus L, t equal to Tw, or if x equal to L, t equal to Tw, anyone you can apply. Say I am applying x equal to L, t is Tw, right? Just put it here in this equation. So what will I get? Tw So you just solve and tell me what is the final output you are getting. So just tell me what is the value of C2 you are getting. What you get? Hmm. Okay, Q double by K L square into 4 by 12. So L square is cancelling out. This is 2, right? That means TW plus 5L square Q double by 12K, right? So just in this form, in place of C2, I can write TW plus 5 by 12K, right? So what is the question asked? At x equal to 0, what is the T naught? The temperature at x equal to 0. Just put T at x equal to 0. So if I put it x equal to 0, that means this whole term will be 0 plus TW 12K, right? So any option there? So, oh, okay. Another thing is given the value of the thermal conductivity, all of them is 1. So you just put 1 and tell me what is coming. TW, L, Q, K, everything is 1. So T is 1 plus 5 into 1 into 1 by 12. So doing LCM, you will get 12 plus 5, that is. So your correct answer is option A. So you got it? So it is say it is a similar procedure as that what has been I shown earlier. But if you see this question, it looks quite complicated. But you have to carefully first derive this equation and after that you can solve. It's nothing, it's mathematics. Okay. So this next question. So 10 more minutes I require. So the question is the temperature distribution T has dash dependence on X. So this is the option. This that means the previous question. It is talking about the previous question. Okay. So if you see in the previous thing, this temperature T, this equation, in this equation, how T varies with X. T is a function of x square x to the power 4. So the maximum power of x is the maximum power of x is 4, right? That means it is a biquadratic. If this x, if the maximum power of x is 2, then it is a quadratic. If it is a 3, that is a cubic, and if it is only x, then it is a linear. So the correct option is your bi uh, biquadratic. You got it? Uh, Now it's a similar question, like the equation you derive here. T is a the form of T is derived. So just say if the value of k is this, find at x equal to 0.1 what will the value. Okay, so you can solve this one in the home, right? So the correct option you will get is option C. So I am not solving this one. Just you do one thing. You just in this equation you just put x equal to 0.1 and all other value as 1. You will get the answer. So this is your next question. This is your thermal conductivity. So the three block composite block means three blocks having different material. So thermal conductivity is K, 2K and 3K. Area and thickness is given same. Okay. So just say the ratio of the temperature drop. That means here it is if it is T1, if it is T2, if it is T3, it is T4. So you are asked to find the temperature drop across this material. That means T1 in the first block the temperature drop is this one, right? In the next block the temperature drop is T2 minus T3. In the third block it is T3 minus T4. So you have to find this thing. So in the question the important thing is that K is only K is varying, all other things are constant. So if say I am talking about an heat flux or heat, as area is given, so I represent it as heat Q. Okay. So if the Q is applying here as this one, so from the 1D conduction equation I can write what I can write, or use the Fourier equation. Better you say it is a Fourier, not 1D conduction equation. Fourier equation is better. Mhm. Or 1D, I say even also it is in 1D conduction equation format, because if you say this 1D conduction format, what is there? Q gen by K is 0, right? So that means del square T by, like that way you will get na. So basically if you derive this you will get the same thing, but I think it is not required here. So better use the Fourier law, because KAL it is given in the Fourier's law. So what is the equation we get from the previous one? You remember that T1 minus T2 by K by LA, K upon LA. This is resistance. So basically I can write temperature drop by thermal resistance, right? Also I have plot you remember this graph I have plot this graph, not this circuit. So if it is T1, if it is T2 and the heat is Q, right? This one is your R1. Next, this is analog to this one. Okay, 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 sorry. Sorry, sorry. Yes, yes. L upon Ka, right? So next it is R2. Same heat will flow. Next it is R3. So if I find out the resistance in each case, so better I find out the resistance first. So R1 is L by Ka, because Ka and L are same. R2 is 2Ka. R3 is 3Ka. I got this R1. Okay. So now this equation, you see here as the heat is flowing from here to here, right? Same Q is flowing. That means Q is constant. So if Q is constant, that means temperature drop is proportional to R. Uh, So this one as proportional. So I can write here temperature drop. That means this is proportional to R1. Can I write or no? So here L by Ka is same in all this. So I can write now L by Ka is to L by 2Ka is to L by 3Ka. So I will get, if L by K is common, so I can remove this one. Ultimately we get, so if I multiplied all the three side into 6, what I will get? 6 is to 3 is to 2. So the correct option is option D. You got it? Hmm. So again, if the total resistance, if someone asks you to find the total resistance, then how will you find the total resistance? Yes, it will be in R1 plus R2 plus R3, and you will get a value equivalent. Yes, if it is in series. Yes, 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 good. So that is the concept. Okay. So similar to that concept, I am giving you a question. So this is the last question for today, because already the time is over for the today. That's why this is the last question. Okay. So just see here, it is again a composite wall, similar to what I have given in the last one, but here the thickness is varying, thermal conductivity is varying. Okay. A composite wall, the composite wall, say here the first K is 0.3 K1, K2 is 0.2, K3 is, right, and next what is given, L. This L1 is 0.3, L2 is 0.2, and L3 is 0.6. And the inner and outer surface temperature, that means this temperature, if this is T1, T1 is given as 500, this is your T2, T3, outer surface, say it is T4, outer surface is given as 20. So you are asked to find heat transfer per unit area, that means your heat flux. So you are asked to find Q. Okay. So K is given, A, all this thing is given a composite wall. So in the composite wall, you need to find first R1, R2, and R3, right? Then you can find out total R. What is R1? R1 I can write, K1 is 0.3A. That means 1 by A, right? And this one is 0.2 by 0.2A. That is also 1 by A. And this one is 4 by A. No? Which formula I have used? If someone asks, Ri is L by A. So that is the resistance. The circuit is looking like this one. This one is R1, R2, R3. And already I have known T1 and T4, and Q is here. So if I know the equivalent R, so I can find. So what is Q? Q is temperature drop by resistance, total resistance. Temperature drop is T1 minus T4 by R total. So what is R total? 6 by A, right? So T1 minus T4 is 500 minus 20, that is your key Q will get 480 na, 480 divided by R total. In place of R total you can write A. So what will get 460 by 8, that is your 80 A. So what is said? Heat flux. What is heat flux? See. So the correct option is option A. So you got the concept. So that concept you will need to utilize in all these fundamental assignment question. You can, I think, the similar types of question will be asked in the assignment, and using this concept you will be able to solve this one. Okay. And another thing is that this video will be already I have shared in my drive. I think you have got this link, na? So in that link, I have given the previous class PPT, and after an hour, I will upload this one along with the YouTube video link. I will share. Okay. So that thing, I think that you will be, that thing will be. One, just a minute. Mm. Yes, yes. Hmm. Hmm. Yes, yes. Hmm. 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 So yes, yes. It is not your problem. Even in my case, because in my time there is no gate in the third year. Though I have appeared for the gate in the fourth year. After that, the gate is from third year. But the issue is that I have also faced the same thing what you are telling. So what I suggest you, as it is in third year, you have not studied about heat transfer even many of the concept in the manufacturing part and even design part. So you may feel that your preparation is up to maximum of 50% or like that you can feel. But it is not that. Already you have studied mathematics, right? So so you just focus on this mathematics aptitude part, because what I remember in the mathematics and aptitude part, marks up to 27 to 30 will come, right? Mm. So, and which are the subject you feel good? Like, tell me few subject in which you are good. Not all subject, one to two subject. Mm. Mm. Yeah. Yes. Mm. Okay. In the you are saying that in the heat transfer you have not solved question, right? Hmm. So just up to today's class, see, in the GATE exam also, whatever has been taught in the today's class, concept like this will be one a simple question will come up to this concept. You can expect, but in the as you have gone through the fluid mechanics, so you just follow this Newton's law of viscosity, because there you will find a definitely you will find a question similar to this concept. Next, whether you have gone through casting. Mm, mm. Yes, 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 that can have something a problem. And industrial engineering, you have gone through? Okay. So in the fluid mechanics, I think in the fluid mechanics, a few questions will come. So you better prepare with this fluid mechanics and whatever you thermodynamics you have gone through. So thermodynamics part you have gone through. You just keep your mind cool and just try. Your target should be like clear the exam initially, because whatever marks you are getting this year, it will boost your confidence in a will boost your confidence significantly. Because if you are trying to have a good marks for qualifying to this, what is it I can say this one, uh, your PSU, to appear for this PSU. So this exam, in this exam, you will first try to answer whatever you know. Like if you are going through mathematics, you first try to understand. It is not required to attempt each and every question. So your first motto is that whatever I will answer, it should be, I have to be confident on it. Okay. So the easy question you first try. Always try the easy question, and after that you try this hard question. So and in the first for the mathematics part, I say that just as the exam is on, what is the date? 14th February. So as exam is knocking at your door, so you just go through your maths part, because maths part is the part which will definitely help you to qualify this gate. Because if you qualify the gate, you will definitely get uh, forgot about the PS, you will definitely get an MTech course at IIT or yeah. So that's why your target should be like you, what subject you have completed, just go through that subject. Do not need to go through new subject right now. That's my suggestion. Okay, and heat conduction up to this part is okay for you. I think for the gate syllabus up to this part, or in the next class, if you it is on cylindrical coordinate, same concept. Mm. So up to this part, it is okay. So okay, any confusion? So you can raise on the next class also, because next class is a class before your uh, gate exam, right? Mm. Okay, so you just go through it. Any more confusion? Uh, so all the best, prepare well, and hope we will meet on the next class. Okay, okay. Thank you, huh? Have a good day.